Alright, so we got three main parts to intro. We have density, physical and chemical, and then the matter, types of matter. So the main key point of density is you have the equation mass times volume. Nope. Density is mass over volume. We do it with a triangle. Men climb the mountain. Density and volume on the bottom. You cover the one you want to find. Units for mass, grams. Units for volume, it's either milliliters or centimeters cubed, not milliliters cubed. Units for density are either grams per milliliter or grams per centimeter cubed. Oftentimes, if you get a trickier problem, it will say something like, what is the mass? So if you want to find mass, it's density times volume, or if it asks you for volume, it's mass over density. Something called water displacement is if you have a graduated cylinder and you have it filled with water, say to the 10 milliliter mark, and then you drop a rock in and it raises to the 20 milliliter mark. That's called water displacement because you're displacing water. So the volume of the rock would be 10 because I just subtract the 2. This makes it a little bit of a challenging problem, but that's really your only twist on density. For physical and chemical, physical change can be reversed, and you don't change the identity. For example, you cut your hair, it's still hair. You cut paper, it's still paper. You tear, cut, stir, mix, dissolve. All those things will have physical changes. So if I dissolve salt in water, it's still salt and water. So a physical change because I didn't actually change the identity of what I have, and I can reverse it. I can evaporate all the water into the air and have water and still have the salt left in my container. A chemical change is the opposite. It can't be reversed, and you change the identity. So while dissolving is a common example of physical, a reaction is a common example of a chemical. So if I react hydrochloric acid and sodium hydroxide. Other examples of chemical changes are if you make anything with bubbles or if you release a gas and you didn't start with one. If you have an unexpected color change. So if you mix two clear liquids and make a yellow solid, that would be a chemical change. If you mix a purple liquid and a red liquid, a blue liquid and a red liquid and you make a purple liquid, not a chemical change, it would just be physical because it's expected. Matter is broken down into two main types: pure substances and mixtures. Pure substances can't be physically separated. Mixtures can be physically separated. Pure substances are broken down further into two other types of things: elements and compounds. Elements can't be broken down any further into anything that retains the chemical identity. So I can break iron down into, say, protons and neutrons and electrons, but it won't still maintain those chemical characteristics of iron. An easy way to tell if something's an element, if it is an element, we put it on the periodic table. So that's a good check. Compounds are made up of two or more elements that can be chemically separated. So, for example, if I have water, like H2O, I can chemically separate it into hydrogen and oxygen, but I could never ask you to go physically separate your water. Mixtures are broken down into homogeneous and heterogeneous. Homogeneous mixtures are the same throughout, so your first drop is going to be the same as your second drop. Heterogeneous mixtures are the mixtures where you can see and they're very different throughout. So like a fruit salad, you can see the different parts. One scoop isn't going to have the same number of grapes as your second scoop. Keys for heterogeneous mixtures, you oftentimes have to shake them or stir them, or they're dairy products like cream or milk, paint, salad dressing, fruit salad. Homogeneous mixtures are also called solutions. So whenever you dissolve something, like dissolving salt in water, you're making a homogeneous solution. Really common examples: air is a homogeneous solution, gasoline is a homogeneous solution, and things that are a mixture of two elements like brass and bronze, they're mixtures of two elements, they are homogeneous solutions.